Hey there, Professor Hildebrandt here. So I'm going to go through and work these review questions that we have for Unit 2, covering chapters 3 and 4 here on probability and our discrete probability distributions, okay? So the first question here, hold on, I'm scrolled down. Oh gosh, I was way down. Okay. So we've got an insurance company, and they're looking at Exxon's oil production platform against weather losses. And so they're trying to predict the probability that they have to pay out, okay? That's what they're doing here. And so the first question says, what's the expected amount the insurance company will have to pay in losses for the year? So expected amount, when you read that, you should read that as expected value, which for a probability distribution, expected value simply means that you need to calculate the mean. Okay, so you need to calculate the mean. So to do that, it's simply the amount or the x value. So the loss here is our x value times its probability of occurring. So a 0 has a 98% chance of occurring, so they'll pay out $0, right? We have a 40 million loss. These are in millions, so this is 40 million times 0.016 or 0.64 million. And then 300 million times 0.004 for 1.2 million. Okay, and then that's an awful, not what I was trying to make here. Sorry, y'all. Then we simply sum. My goodness, I'm trying to write in on my iPad with it propped up, and that's not working too well. Okay, so we sum all of those up. So we have 0 plus the 0.64 plus the 1.2, and the expected amount is 1.84 million. So that is our answer for the first part of this question. What is the likelihood that the insurance company will lose, this should say, less than the expected amount? And that means that we would be paying 0, right? And so there's a 0.98 chance or a 98% chance that would happen. And then finally, if the insurance company suffers a loss, what is the likelihood that that is for 300 million? Okay, and so we take that probability here for 300 million of 0.004, so 0.0004, and we're going to divide that by just these two probabilities here, because it says if the insurance company suffers a loss. So this first one, we don't suffer a loss, so we're ignoring that one, okay? So if they suffer a loss, what's the likelihood that it's 300 million? So we add together plus the 0.004, and then once we divide that out, you would get an answer of 0.2 or 20%. So there's a 20% chance that if they do have a loss, that it would be for $300 million. Okay. Now let's look at some cards. So the first card selected from a standard deck of 52 cards is a king. So first we're looking at if the king is returned to the deck. So we're back to 52 cards. What's the probability that a king will be selected on the second pull? Well, there's 4 kings in a standard deck. And if we've returned the first one, there's 4 shots to get a king out of 52. And so our answer here is 0.077 or 7.7%. Okay? But what if it's not returned? If the king is not returned, what's the probability that a king would be selected on the second pull? Well, that means there's only 3 kings remaining in the deck out of a total of 51 cards. And so that's 0.059 or 5.9% chance. Okay, and then the last part of this question, what's the probability that a king would be selected on both the first draw and another on the second draw? without replacement when the first card is not returned. So for this, we're going to use what we call that general rule of multiplication. Okay, and so what's the basic probability, classical probability that it's a king on the first? Well, we found that is 4 out of 52. And then what's the probability we pull it on the second? Well, that's 3 out of 51. If you recall from class, this is similar to the golf shirt example. Would he pull a white, or I think it was a blue or something like that, golf shirt out? So we multiply these out. We would get 12 over 2,652, or 0.0045, or 0.45%. So you can see it's very, very rare, right, that we would pull a king on both the first and the second draw. Okay, moving on to our third question. Here we have a breakdown of Congress by party affiliations, okay? And so this is a contingency table, right? And so it shows us different information about some variables. So we have this broken down into, are they part of the House or the Senate? Are they Democrat or Republican? And then you can see the total numbers over here in this column. So A says, a member of Congress is selected at random. What is the probability of selecting a Republican? Okay. Well, how many Republicans are there total? There are 300. Okay, so 300. Out of the total amount of representatives of Congress, 534. And so it's simply 300 divided by 534, or you would find that's 56.2% chance that that randomly selected person from Congress would be a Republican. All right, well, let's look at a little more difficult one. Given that the person is in the House of Reps, okay, what is the probability that he or she is a Republican? So for this one, we're only looking at this first row here. We're only looking at the people that are part of the House. And again, we want to know the chance that they are a Republican. So there's 246 Republicans in the House out of a total in the House of 434. And so the probability here would be 56.7%. Okay? And then the final part of this question, let me get a different color here. Here we go. What is the probability of selecting a member of the House of Representatives or selecting someone who is a Democrat? So here we're talking about, let me write this out for you. So the probability that A or B happens is simply the probability that A occurs, okay, that they are a member of the House of Representatives, plus a probability that B occurs, they are a Democrat. But then we have to subtract the probability that they were both, because there's some overlap here, right? These are not mutually exclusive. They can be both in the House of Representatives and be a Democrat, okay? So the probability that they are in the House of Representatives, well, there's 434 people in the House of Representatives out of a total of the 534. So that'll be the probability for that one, okay? And then plus the probability that they are a Democrat, well, there are a total of 234 Democrats out of that 534. And then we subtract, again, the probability that they are both in the House and a Democrat, which is House here, Democrat there. So this 181 minus the 181 over 534. And when you work this out, it comes to 0.899 or 89.9%, okay? Because these numbers here would be 0.813 plus 0.438 and then minus 0.352, okay? So there's the math for that one. Okay. A case of 24 cans contains one that is contaminated. 3 cans are to be randomly selected for testing. So this is going to be how many combinations of 3 cans can be selected. So here we're going to use that combination formula. 3 is going to be my R. That's what I'm pulling. And then my N is 24. There's 24 total cans. So let me come up here. So using that combination formula, R and then N minus R factorial. Okay, so we're going to plug in here. It'll be C of 24 and 3. So we have 24 factorial over 3. Sorry, y'all. 3 factorial times, my hand's getting in the way, 24 minus 3. Okay, so we need to work that out. So we'll have 24 factorial over 3 factorial. 24 minus 3 is 21. Okay, so this is 24 times 23 times 22 times, it would be 21 dot dot dot, right? But that 21 factorial then will cancel out with those. We're left with 3 factorial, so 3 times 2 times 1. So this is 12,144 divided by 6, or there's 2,024 different combinations of 3 cans that would be randomly tested. So we would have 2,024 different combos, okay? Because again, order doesn't matter on this one, so that's why we're using the combination formula. The director of admissions at a university estimated the distribution of admitted students for next fall based on past experience. So we might have 1,000, that's a 60% chance. We'd have 1,200, a 3% chance, or 1,500, a 10% chance. What is the expected number of admissions? So again, when you see expected number, you should think, what is the expected value? An expected value for probability distribution simply means, that's an N, sorry y'all. Those medicines, I guess, have me loopy. Expected value is simply your mean. So you're summing up, right, each of the X values times its individual probability, okay? So 1,000 times 0.6, okay, and then we'll have, and so that's 600, and then 1,200 times 0.3 for 600, 350, or excuse me, 360. Maybe I'll get this right in a second, y'all. And then 1,500 times 0.1, or 150. And so we would find that the mean or expected value is 1,110 new students. Okay, and then we could also find the variance and the standard deviation for this university. So let's do that. Okay, so my formula for variance is going to be summing up each of the X values minus the mean squared times its probability of occurring, okay? So we'll sum all of those up to find the variance. So I'm going to make myself the little chart like I like to do. Y'all should know this by now. So we have 1,000, we have 1,200, and we have 1,500. And then the probability of occurring, right? All this I'm just taking from the chart, you guys, 0.6, 0.3, 0.1. All right, so my first column is X minus the mean. My next column is then that amount squared. And then lastly, I'll take that amount squared and multiply by its probability of occurring, okay? So 1,000, and each one we're going to be subtracting from, I have a different color, this 1,110. So 1,000 minus 1,110 gives me negative 110. When I square that, it gives me 12,100. When I multiply by the probability of 0.6, I get 7,260. Okay, so that was my first one. All right, so my second, 1,200 minus 1,110 gives me 90. 90 squared is 8,100. 8,100 times the probability of 0.3, is 2,430. All right, almost there. And then 1,500 minus 1,110 is 390. 390 squared is this nice big number. Multiplied times the probability of 0.1 is 15,210. And then again, I come in and I sum these up. And so we would get 24,900. Okay, so that is my variance. So my variance, which again doesn't have much meaning, but 24,900 students squared, right? Doesn't make much sense. So then what we're going to do is we're going to find our standard deviation. And remember, our standard deviation is always simply the square root of our variance. So my standard deviation here is the square root of 24,900, or 157.8 students. That's the spread in my probability distribution. Okay, guys, this is it for the Unit 2 review. I covered everything except for uniform distributions, but we did a lot of those in class. So hopefully this helps you guys prepare for your exam.